Okay, so now we're going to look at the 8 steps of the engineering and design process. So all engineers use basically the same process when they are designing something. So first we need to look at the relationship between science, engineering, and technology. So we've got science over here, which seeks to understand the natural world, and it often needs new tools to help discover the answers. We have engineers here, and engineers use scientific discoveries to design products and processes that meet society's needs. And you can see that science and engineering overlap. The third part of our equation is technology. Technologies, or products and processes, are the result of engineered designs. They are created by technicians to solve societal needs and wants. So you can see that science is related to engineering, okay, because it uses new tools. So engineers use scientific discoveries to design products, which are technology. Technologies are the result of engineering, and they create solutions to the needs that science and society has. So they're all interrelated. So there are 8 steps of the engineering design process. So the first one, step 1, is to identify the need or problem. So let's say we're talking about an insulin pump for diabetes. So the original need or the problem was that to design a way that a person with diabetes could get a continuous supply of insulin through the day. So that was the first step. So we need to think about the challenges that the problem poses. Well, throughout the day, they're going to need different amounts of insulin. When they eat, they're going to need more. When they exercise, they're going to need less. Then we need to think about what requirements the solution must possess. So what should the length of it be, the height, the weight, the function, what does it need to do? How should it look, right? How big should it be? What should it be made out of? Okay? So, for example, my daughter who uses one, she's 8, so she, wants it to look pretty. So, originally she had a purple one, then they came out with the pink version. She had the pink version. Now she's moved on to the blue one, and then they've created skins for it. So now hers has peace signs all over it. So they've made it aesthetically pleasing. That's what aesthetics means the way it looks. Step 2, we need to research the need or the problem. So when they were designing this, the engineers had to do some research. They had to look at what do they currently have, okay, what's the current issue, okay, which was insulin shots. So those were the current solutions, and then you would give yourself a shot of more or of less depending on what you needed. And then they did more research. They had to, in the internet, look what's the current technology, what's the current goal, where do scientists or doctors who study diabetes, where do they want it to go, what's their end goal, right? Look at the library, okay, that's a place with books in it, it has lots of information, you can go there, every town has one. Also interviews. So interviewing people who have it, who live with it every day, right? Interviewing patients, interviewing doctors. What is it that they want? What are their needs? Step 3 is developing possible solutions. So then this is where you're going to do your brainstorm. You're going to use math and science to develop possible solutions. Demonstrate the solutions by drawing them to scale. So a 3-dimensional view of it, 2 dimensions, right? How's it going to look from different angles? How wide is it going to be? How thick is it going to be? Is it going to be able to fit in your pocket? How are they going to hook it onto themselves? Right? And then refining the possible solutions. So taking those possible solutions, doing more research, talking to people, looking at, talking to people who have to wear it, talking to doctors, looking at, okay, what do you think of these designs? What do you like about them? What do you not like about them? And then changing them or refining them based on those answers. Step 4, okay, is selecting the best possible solutions or solutions. So looking at all the different solutions that you've got and determining which solution or solution best meets the original requirements. So looking back at that original goal, okay, this is a big part of engineering. It's always referring back to the original goal, always referring back to the requirements. Okay, just like we like you to do on a rubric, go back and look at it when you're writing it to make sure that you're doing what you're supposed to be doing. Engineers are constantly doing this. So they're constantly going back to the original problem. What is it that they're trying to solve? What is it that they need the product to do? Okay? Once they've done that, then they're looking at the different solutions that they have and determining which solution best meets those requirements, which best solves the problem. Step 5 is constructing a prototype. So you've got all your drawings, you've looked at them all, you've decided which one, right, best meets the requirements, and then you're going to take and you're going to create a model of the selected solution or solutions in 2 or 3 dimensions. So right here they've got a model of a bridge. So you're creating a scale model, okay? If you're doing something like a bridge, obviously it would be smaller. If you were doing something like an insulin pump, you could make it the actual size that you intend to make it, which would be a scale of 1 to 1. Step 6, you're going to test and evaluate the solution or solutions. Does it work? Did the insulin pump that you designed, does it work? Does it do what it needs to do? Is it easily breakable? Okay, because in a lot of cases you have small children, young children who are wearing them. People who are playing sports, doing all kinds of activities are going to be wearing these things. Does it work? Does it meet the original design constraints? So, if the company said it cannot be any bigger than a certain size, does it fit into that constraint? If they said it has to perform these functions, does it do that? Okay, so that's in this testing and evaluating the solution part. And this is where you're going to be looking at things like, people will be doing trials and things in this. Step 7, you're going to communicate the solution. So this is when you're making an engineering presentation that includes the discussion of how the solution best meets the needs of the initial problem, the opportunity, or the need. And so this could be as simple as a meeting with your design group. This could be a huge press conference. And then you are discussing also societal impact and trade-offs of the solution. So what is a trade-off? Okay, so a trade-off, if you've ever seen the movie The Lorax, right? They create these SNEEDs, okay? But the trade-off to the solution is they cut down, and this is also the societal impact, how it impacts the people. They cut down all the truffula trees. So that was the trade-off, okay? This is how it impacted society. So those are things that you need to consider, and you would consider this in this step 7. The last step is the redesign. So this is when you're going to so you've made your presentation, you've presented it to people. Now people are really testing this thing out. And this is when you're going to overhaul or change the solution based on the information that you gathered during the test and the presentation. Okay, so say you've taken your insulin pump and, now people have done trials wearing it, and you've, in your presentation, some people brought up some other points. Now you're going to go back and you're going to recreate what you had originally done to fit the problems that you found out about during the testing phase. Okay, so let's say you had this insulin pump, somebody wears it during, while playing soccer, right, and it gets dropped, and it breaks very easily. So that's something that you're going to consider in this redesign. or people are saying, you know what, I'm running out of insulin before I should. So you need to make the place where the insulin goes bigger so it can hold more insulin. So that's when you would find this out, and that would be part of this redesign. And from the redesign, that's when you go right back to step one and you start all over again. And so that's how the engineering design process works. So you might go through these 8 steps several times to create one product. And so that's why you'll see the 8 steps listed as a circle and not in just a straight line.